Hello, I'm Mr. Muskaluk, your chemistry teacher, and I want to teach you some chemistry. And the first part of chemistry that we're going to deal with is matter. Now, you're watching this to learn about matter and elements and compounds, but really, you should have looked at the summary first. You should make sure that whenever you go to any type of lecture or demonstration, that you don't walk in cold. What you've got to do is go through so you know what's going to be said. So as you listen, you'll be able to understand more and get a greater value from the time that you're watching a video. You'll be able to consciously go through and say, oh, yeah, I know that, but this I want to listen to a little bit more because I didn't understand it. Or there's a great example that I learned from. So never ever go into a class cold. You're going to be missing so much of it. That's my first piece of advice for chemistry and any type of instructional video that you're going to watch. So if you haven't looked at the summary for this unit, and here I'll show you the summary, then go back and look it over, read it, see what you understand, what you don't understand, and then come back and pick it up right here. And I'm sure you'll enjoy and understand more of what I'm saying because of that extra bit of effort that you put in. It's worth it. Okay, so you already know a little bit about this. So you've seen this diagram before. You know that we're going to start in chemistry discussing matter. Now, matter is stuff that you can see and hold. We'll also have another section on energy, this stuff that you can't hold. In fact, it's interesting. That energy is contained in this flashlight, and when I turn it off, it's still stored there, and now it's being released. Energy will be interesting, and we'll get to that in the next series of lectures. So let me put this away and get to matter, because it does matter. Okay, it's going to take up space and volume. I mean, we're designed to be able to touch things. I mean, we've got sensors on us that let us understand and feel and recognize matter. You also have sensors in your eye and in terms of heat and cold to recognize energy. So we're equipped to understand and see this stuff in the world. Let's start and see our organization. We've got pure substances, okay? And then we've got mixtures. And let me start with the pure. We have pure that's divided into elements and compounds. And sometimes I'll say pure substances. So let me pull out an example of a pure substance. Here we go. I've got a nail. It's taking up space. I can hold it. I can feel it. This is Fe, iron. Chemistry is fun because I mean, who would know that Fe is iron? It comes from the Latin ferrum, but right now this is our iron. And let's see some of its properties. I've got a magnet here. Oh yeah, it sticks to the magnet. This is iron. I can pound this to flatten it. I can stretch it out. In fact, that's how they make these iron nails. So that's an element. And I'm going to look at my periodic table, and you should have a periodic table already. This is the AP one, and if I look around, I'm going to find Fe right about here. See Fe there. So all these elements, there's only 100 of them, about 100 of them, are listed on this AP periodic table. Use that, don't use any other periodic tables. So we've got an element, it's there, fine, iron. We'll find out its classification as a metal later. And here I've got a yellowish powder. It's really pretty. It's almost a yellow green, pretty common. Now, iron, you're only going to find that on Earth in terms of meteorites as an element. It is pretty reactive, so if there was any iron around, it would have changed into rust, but that's a compound, that's later. Sulfur, you'll find quite a bit. If you're near a volcano or an area where there was volcanic activity, you're going to find sulfur around. It's odorless unless it starts to burn. And then it's not sulfur anymore, it's something else. So this powder is sulfur, and we should be able to find it on the periodic table. Let's see. Here we've got Fe, and right over here we've got sulfur. Look it up on a table. You should be able to spot sulfur. We use it a lot in our chemistry experiments. So I've given and gotten two elements. These things are, I mean, I don't care where you get this sulfur. If you get it from Pompeii, if you get it from Yellowstone, it's going to be the same thing. It's made of atoms that have a certain characteristic that make this stuff what it is right now. And the same thing for this iron. If you find an iron meteorite on in Alaska, or if you find it somewhere in the equator, it is still going to be the same stuff, same density. It is iron, period, made of iron atoms. Now, oh, by the way, yeah, the sulfur is not magnetic. If you put iron powder and sulfur together and give it some time, you're going to get this. Let me turn on my camera so you can see it a little bit better. I'll turn on my other camera, switching to it right now, and look at those beautiful cubes. That is just super pretty. Now, this stuff, which is a pure substance, is made of the yellow powder, sulfur, and iron. But it doesn't look like either of them. It's totally different. And it's not magnetic. So it doesn't have the characteristics. Let me switch back so you can see me. Here we go. I've got this is FeS2, iron pyrite. In fact, one of the reasons it's called pyrite is that if you hit it with some metal, you'll get some sparks, a little bit of pyrotechnics. This is a compound because it's made of two elements, but still a pure substance. Whether you get this out of a mine in Poland, where this came from, or you get this in Yellowstone, it's going to be the same formula, the same amount of iron, the same amount of sulfur. A compound takes these two pure substances and produces something that's totally new. We only have about 100 elements. No, this is it, the periodic table. Now, if you were, yeah, I guess you could memorize them all, but compounds, because there's so many different ways to make them, I mean, they're innumerable. The chemical handbook, I should pull one out. It's like about that thick and with thin paper, and it only contains a fraction of the possible compounds. And that's sort of nice. Now, chemistry is the study of change, iron and sulfur. Voila, change. And we get all sorts of things with it. Yeah, that's one reason I like chemistry, because you can make all sorts of stuff with it. So here we go. I've got elements and compounds, and these formulas tell you about the atoms. We're going to have two sulfur atoms combined with every one iron atom. If you zoomed into here and could see the atoms, you would see iron and sulfur somehow bound together. And that we'll get to later. Okay, here I've got something on the side. Now this is very, very visible and easy to spot. Let me pull this out, because sometimes matter can be hard to see. Here's our example. I've got here the first of all the elements. If you count from 1 to 100, iron, let me get my glasses on, is element number 26, sulfur is element 16, and hydrogen is 1. This is the primo element. In fact, there's more hydrogen in the universe than any of these things. It's everywhere. So I've generated some hydrogen, and these two tubes are filled with it. And I've got it listed here as an element. But there's something strange about this element. You can't have hydrogen atoms all by themselves unless they are far apart or in weird situations. Hydrogen is a diatomic substance. Hydrogen atoms, as soon as you have more than one of them, will come together to make H and H. They'll stick together. Now, this is sort of like a compound, but we still call it an element. We call it a diatomic element. So I say H2. So we're starting early, and you'll find out that we're going to be dealing with quite a few diatomic elements. In fact, in your summary, I'm asking you to look them over, to recognize them, to spot them. Because whenever you write a formula out, you're not going to write H hardly ever, unless they tell you that is atomic, lone hydrogen. You're going to write H2. Otherwise, you're going to embarrass me. Please, please don't do that. Say, hey, my chemistry teacher said H2, whoops, and all the other diatomic elements. Look at the summary. You'll find a fast way to find the diatomic substances. A little side note, sulfur is octatomic. We'll get to that later, but that's sort of a detail we don't have to know right now. So I have some hydrogen. I have a pure substance. Of course, this is chemistry. And one of the reasons I love chemistry is because you can do neat changes. So I'm going to take this pure substance, hydrogen. You'll notice I'm holding it here in this flask. I can't see it. Now, if I chilled it down to a couple of 4 degrees between just above the coldest possible temperature, I'd get a couple of drops of hydrogen liquid. It'd still be H2. Right now, it's a gas. It's pretty invisible. You're not going to see it. There's some fog in here. And it's lighter than air. So if I tip it upside down, it's going to escape. But it'll take a little while. And when I tip this upside down, it's going to mix with air, which is a mixture. And air has oxygen in it. Let me see if this doesn't tip over. And I'm interested in the oxygen. Don't tip. All right. Keep our fingers crossed. I'm going to take hydrogen and I'm going to take oxygen. If you check the summary out, oxygen is diatomic too. And I have a mixture of them. Also some nitrogen here. If I turn this up for a few seconds, some hydrogen escaped, some oxygen got in, and I'm going to change my mixture of elements. Holy cow, that was beautiful. Oh, I love chemistry. Oh.